Hello, everyone. I hope you're doing well. Today, we're going to be continuing with carbonyl addition. We talked about like how we react to ketone with um, with alcohol and acid to make ketol and hemiketol and acetyl and hemiacetyl. Today, we're going to talk about like what if we instead of reacting alcohol, we talk about like amine, like nitrogen. So nitrogen is nucleophile. So yeah, okay. So again, putting it so first of all, the first function group that we're going to talk about now is called imine or imine. I think it's called imine. So imine synthesis. So it's uh, a reaction of ketone or aldehyde. Again, remember we said ketone and aldehyde doesn't make a single difference. Which one you have? With an amine with two or three hydrogens. You're like, why would the number of hydrogens make a difference? Well, you'll find out. So let's say we have a ketone and we have an acid. And then we had, let's say, NH2R. So instead of like two nitrogens attacking this, instead, this nitrogen loses two of its hydrogen and does a double bond here. So it will be like this. And then whatever you have left, it could be a hydrogen, it could be an R group, whatever, it will be like this. So, so this will be imine. So imine is a nitrogen double bonded to a carbon. So it's very distinctive. So you are not going to see it anywhere else, like in their course. So you're like, why does it need to have two or three hydrogens? Well, because again, look, again, we're going to show the mechanism, of course, but in order for this to make a double bond with something, it needs to lose two things, lose two bonds. So that means that it needs to have at least two um, to to lose, so you can replace those bonds with like the carbon here. And the only bonds you can ever lose are hydrogens through acid base. So that's why it needs to have at least two or three. And then you're like, what if it has only one? Well, that goes into the next topic, which we'll talk about that. Like next, like a section, like next topic after this today. And again, yeah. And so for example, if it was um so NH3, so that would be just NH. So again, pretty much the nitrogen, what I guess the 12 is hydrogens. Whatever is left is going to be there. And just like before, these reactions are reversible. So meaning pretty much you can actually use an acid and H2O to make ketone or aldehyde, whatever that it came from. Yeah. Is it really that different than what we've been doing? No. Actually, most of the reaction is the same. But because you're going to make a double bond instead of attacking it twice, the mechanism is different, which you probably can imagine how I get the double bond, because pretty similar like how we make a double bond here. So let's do an example. So very similarly, you see this goes here and it goes here. And it breaks. Again, so far the same thing. For a while, it's going to be similar. So, and then the amine attacks. I mean, we don't have a thing called hemi-imine, but if there was, it would be this. But then we're like, okay, so this guy has to leave. How do we make it leave? Obviously through protonation. But then, so obviously, again, we know that another nitrogen is not going to come in. Instead, it does resonance. Ta-da! So you see, again, like how I said you have to sacrifice two bonds to make this happen. We lost the hydrogen here, and we lost the hydrogen here. And then instead, now you got that nitrogen double bonded to this carbonyl. Still, we only make and break bonds with the carbon that we're focused on.